Although software evolution starts from day one of software development, it is really the software maintenance and operations phase where problems due to software evolution start to surface. Next, we will look into software maintenance and operations from the process viewpoint. There are several characteristics that differentiate software maintenance from greenfield software development. First, an existing system comes as a constraint. The first obvious type of constraint is the existence of an architecture. So any modification that one does need to take into consideration the possibilities and the limitations of the existing architecture. With existing architecture, it is also extremely likely that there is existing data in the existing system. This implies certain database schema for storing and accessing it, and therefore more effort is required when one wants to, for example, change the existing schema, as one has to ensure backward compatibility. Existing systems are also typically used by other systems. So in this case, when we modify the existing system, we must ensure that we don't have unanticipated impacts to other systems due to which we have built interfaces on. And this is another concept that sort of makes the backward compatibility more important. And by backward compatibility, we mean that making sure that new versions of the same system can still be used the same way as the previous versions of that system. So if we think about a function or method of part of an API, we need to ensure backward compatibility that the future versions of the same function or method will keep the same signatures and produce the same results as the current version. Software maintenance usually happens over a shorter time frame than a greenfield software development. This is particularly true in traditional software development, relying still on the Waterfall model, as developing a large system often can take months or even years. While the maintenance activities, even on a larger system, typically happen in a less than a month or even a week or in a day. Finally, having an existing system implies that there are already existing tests. And this is actually one of the benefits of doing software maintenance if you have the tests. So you can actually do the changes somewhat quicker if you have automated tests that ensure that the system are still working as intended. So we don't need to write tests for each change, as we can rely on the existing tests and make sure that the changes do not break the existing functionality of the system. Obviously, if we do not have automated tests, then the maintenance becomes a huge burden, as manual regression testing is needed to ensure that nothing has been broken during the software maintenance operations. Traditionally, maintenance and operations is a phase in the Waterfall development model. In a Waterfall development model, the system is first defined in the requirements phase. Then we do the system design. Then we do implementation and unit testing. And after the system is integrated and system testing, the system can be deployed. And after that, the maintenance and operation phase begins. It is important to notice that in the maintenance and operation phase, we have two somewhat distinct activities. We have the maintenance of the system, and this means, doing enhancements, doing bug fixes, doing performance improvements, and sort of what you would do typically in software development. Then we have the operations, activities that are becoming ever more important. This ensures that the system operates as intended, and there are activities outside of software maintenance that need to be taken care of. For example, we need to take care of that we are not running out of disk space. We have to monitor the system load, system security, and other types of external events that only concern software operations but not software maintenance. Studies done on the waterfall model have already shown that software maintenance and software operations is actually the phase that consumes the most resources during the software lifecycle. So a number as high as 67% has been shown to come in the operations and maintenance phase, while only the remaining 33% are left in the greenfield software development. And with the greenfield software development, I'm referring to the waterfall phase, where the system is developed from requirements, design, implementation, and testing, and then delivered. And if we consider these different phases, we can see that a lot of the software engineering education focuses on the greenfield software development, on the initial requirements engineering, on the implementation as a greenfield, and a testing as a greenfield activity. While in the real world, you are very likely to encounter these operations in the maintenance phase. Obviously, nowadays it is common that software is developed using the agile software development approach. In agile context, development happens in cycles. So in this figure, we can see that we have a product backlog, which is basically the agile way of saying the list of requirements that need to be implemented for the whole product. Then we select a subset of these requirements in the sprint backlog. And then during this 30-day sprint, we implement these requirements that have been selected, and we deliver working increment of the software. It is quite possible that this working increment of the software is already developed to the operations and it is used by the customer, or it might be just used for progress demonstrations internally in the agile process. Yet, in many ways, most of today's software development is about maintaining software rather than developing one from scratch, as sort of the next iteration starts by looking at what is in the working increment of the software and then selects new requirements for the next sprint backlog, and on we go. Next, we have the Devops model, which is basically an extension of the agile software development to also include operations in the loop. We can see the agile phase here on the top. So we have the plan, code, build, test, and these four activities that typically ongo in the agile software development. We can also think of it as a sprint. So we can think this sprint existing in here. And what the operations, the DevOps adds is the cycle coming back. So it's the release, deployment, the operations, and the monitoring. And this monitoring and operations information actually informs the next release. So whatever becomes the plan, is this monitoring feedback is also taken into account. So it is not only the product backlog that matters, but also the monitoring results dictate what happens in this planning phase. In Devops model, everything is sort of post-delivery, everything is in a maintenance phase, as there already is an operational version in use. In DevOps, maintenance and operations phase of the waterfall model is the natural state of the software. And here we have the stage models. And this is different from the previous models, as the previous models aimed at describing different ways of conducting maintenance activities. The stage model is different, and it tries to describe a sort of a longer view of the evolution, like a bird's eye perspective. Rather than focusing on managing short-term maintenance releases that may range from a few months to even few days, this model is sort of like we are talking with each box lasting years, for example. So the idea is that long-lived software systems go to different stages. And as a first stage, we have the development of the initial version, which ends with the first running version released to the production environment. Next, we have the evolution phase that may last years, during which evolutionary changes are made to the system. These changes range from bug fixes to feature improvements and even beyond. According to this model, over time changes occur, and as a consequence of L1 laws of software evolution, the system becomes more difficult to maintain in the evolutionary phase. And at some point the system maintainability might degrade so low that it loses its evolvability, so it can no longer be maintained. In addition, developer knowledge of the system might degrade, so the original developers are gone, the system was programmed in Fortran, you can no longer find a Fortran programmers, so then you cannot no longer make any big changes to the system. So adding new functionality becomes difficult, too time consuming and too costly. As this happens, then it's mandatory that the system is moved into the servicing stage. So once we enter to the servicing stage, no longer are functional or architectural changes made to the system. Basically, we only serve patches, bug fixes for the most crucial issues. At some point in a system's lifetime, there will be a time when the servicing is also discontinued. There can be different reasons for that. They can be business reasons, or they can be technical reasons. At that point, the strategy of the phase out is defined. And after this sort of phase out phase, the system is no longer offered in use. During the phase out phase, you can still use the system, but no changes are made to the system. So the system might still be running, you can still do stuff with it, but as no longer patches are made, it becomes increasingly difficult to use the system. And at some point the system is no longer offered, so then it's closed down and it's no longer for use. For the same model, we can also have the sort of multiversion model, where we first have initial development, then we have the evolution of the first version. At some point, we decide to move this into the servicing phase, and after which it goes to the phase out and close down, while the development is continued in the main branch with the new evolutionary version, and so on. So basically what this means is this version 1 enters to the servicing phase. It means that the new version it will be coming out, evolutionary version 2, that is released at some point. This multi-version model becomes easy to understand if we look through the example of Microsoft Windows. Here we can see the different versions of Microsoft Windows. We can sort of guess that at the moment initial development is ongoing for Windows 12. They have not at this moment publicly announced it, but I've sort of guessed that initial development is ongoing. Windows 11 first version has been released, so it is entering the early stages of this evolutionary phase. They are also still doing enhancements to Windows 10, but it is sort of at the end of its evolutionary stage. Windows 8 is in the servicing phase. They are still serving patches to it, but it will be discontinued at some point, so it's sort of ending the servicing phase. And in a closed down phase, we have multiple versions that are no longer supported of the Windows. We have Windows 95, Windows 98, Windows XP, Windows 7, Windows Vista, and so on. And although this model claims that loss of evolvability is the reason why versions are moved to the servicing phase, from the Microsoft Windows viewpoint, it is more likely that these are business decisions. So they move the old version away and then they implement the new features in the upcoming versions. So it's obviously it's the same code base, but they just decide to sidetrack the old versions. for business reasons partially, and maybe partially also for technical reasons. They might abandon some code in Windows 10, for example, and then they re-implement it in Windows 11 with some type of a better approach. But most of the code base obviously changed the same. I mean, Microsoft Windows has several million lines of code, so there's no way they could rewrite everything between the versions.